C2.1 Structure and Bonding. In this section we're going to have an overview of bonding, then we're going to look at ions and ionic bonding, the ionic bond itself, and how we work out the formulae of ionic compounds. Chemical bonding uses the outer electrons of an atom. These outer electrons are either transferred or shared between atoms, so that each atom has the same electronic structure as a noble gas. That is, they have a full outer shell. Remember, noble gases are unreactive. This is a really stable arrangement of electrons. You're going to need to understand three types of bonding: ionic, covalent and metallic. Ionic bonding happens when a metal and a non-metal react together and electrons are transferred. Covalent bonding occurs between non-metals, and here electrons are shared. Metals use metallic bonding, and we're going to discuss more about that later. When metallic elements and non-metallic elements react together, they are going to form ionic compounds. The metals will lose one or more electrons and become positively charged ions, and the non-metals gain one or more electrons. And because electrons have a negative charge, they become negatively charged ions. And then, and this is the bit that most students forget to write, the oppositely charged ions are attracted to each other, and these forces of attraction are strong. Sodium chloride is a popular example with examiners, but the principle is exactly the same whichever group 1 metal and group 7 non-metal is selected. The sodium atom has one electron in its outer shell. It loses this electron, and now it has the stable arrangement with a full outer shell of 8 electrons and a positive charge. It has become a sodium ion. The chlorine atom has 7 electrons in the outer shell, and it gains an electron, completing its outer shell to give it a stable arrangement. And because of the extra electron, it has a negative charge. The chlorine atom has become the chloride ion. In fact, we can say that one electron has been transferred from the sodium atom to the chlorine atom to form sodium and chloride ions. The ions have opposite charges and are strongly attracted to each other. This is the ionic bond. Magnesium oxide is formed in a similar way, except that magnesium is in group 2, and so it loses 2 electrons to get the electronic structure of a noble gas and forms the Mg2+ ion. Oxygen, which is in group 6, gains 2 electrons which complete its outer shell to form the O2- ion. And then the ions bond together. Ionic compounds are held together by strong electrostatic attractions between the oppositely charged ions. They act in all directions, so each ion in sodium chloride is attracted to 6 of the opposite ions to give a giant lattice structure with alternating positive and negative ions. Now I'm going to explain how we work out the formulae of ionic compounds. In the exam, you're always given a data sheet. On one side there's the periodic table, and on the other side you will find the formulae of many common ions. And you can see that elements in group 1 always form 1+ ions. That's because they've got one outer electron, and when they lose this, they're going to have one more proton than electrons, so the ion formed has a charge of +1. Elements in group 2 have 2 outer electrons, and both of these are lost to give the electronic arrangement of a noble gas. The ion formed has a charge of 3+. Aluminium is in group 3 and has 3 electrons in the outer shell, so when aluminium reacts, it is going to form the Al3+ ion. The charge on the ion depends on the number of outer electrons. You can use the data sheet to work out the formulae of many ionic compounds. Ionic compounds are neutral, so the charges on the ions must balance each other out. Sodium fluoride has the formula NaF because the sodium ion has a +1 charge and the fluoride ion has a -1 charge, and so the charges balance. Calcium hydroxide has the formula CaOH2 as the calcium ion has a 2+ charge and the hydroxide has -1, so we need 2 hydroxides to balance out the charges. The brackets show that we have those 2 hydroxides. Don't forget, if we left out the brackets, our formula would suggest that we would have 1 calcium, 1 oxygen and 2 hydrogens, which is something else entirely. Aluminium oxide is a little bit more tricky because the aluminium ion is Al3+ and the oxide ion is O2-. We need to have a formula of Al2O3, that's 2 aluminiums and 3 oxides, in order to balance the charges. Non-metals bond together by sharing pairs of electrons. This is called covalent bonding. Group 7 elements such as chlorine have 7 electrons in their outer shell and so need just 1 more to have a complete shell of 8 electrons, the stable noble gas arrangement. They can achieve this by sharing a pair of electrons, with 1 electron coming from each atom. Covalent bonds are always pairs of electrons. Now oxygen is in group 6 and has 6 outer electrons. For oxygen to get the noble gas configuration, we need to gain 2 electrons, and so it will share 2 pairs of electrons. This is a double bond, and we can draw a dot and cross diagram to illustrate it. Or we can show a double bond like this. The 2 lines represent a double bond, not an equal sign. 2 different nonmetals can join in the same way, and you need to be able to complete dot and cross diagrams for HCl, NH3, H2O and CH4. Remember, nitrogen is in group 5, so it needs to share 3 electrons and will form 3 bonds to gain the stable arrangement. And carbon is in group 4, so it needs 4 more electrons to gain a full shell, and it will form 4 bonds. Hydrogen, on the other hand, has only got 1 electron, but the first shell can only hold a maximum of 2, so it makes 1 bond. If you use dots to represent the electrons in one element and crosses for the other element, it will make it easy for the examiner to see that you really understand covalent bonding. That covers ionic and covalent bonding, and now we're going to have a look at how the bonding affects the properties of substances.